Okay, so matrices part 2. So last day we had the question where they asked you to simply set up this pair of simultaneous equations in the format ax equals b. But today we're going to move further ahead and we're actually going to solve for xy. To solve for xy, we actually need to make that matrix the subject of the formula. To do so, we need to get rid of this matrix here by carrying it across the equal sign. Now with matrices, when you carry a matrix across an equal sign, it becomes the inverse of that matrix represented by that -1 as the power. And we rewrite that matrix that already was there second. Now there's a reason for writing it second and not first. This here is a 2 by 2 matrix and this here is a 2 by 1 matrix. Remember the rules of matrices. If your matrices are next to each other and after you name them, the inner numbers are the same, then they can be multiplied and the result would be a 2 by 1 matrix. So had we placed this matrix in front, we would have had a 2 by 1 matrix next to a 2 by 2 matrix. And clearly, these inner numbers are not the same, so therefore multiplication would have been impossible. So it's very important that you put the matrix you carry across the equal sign, that 2 by 2 matrix, first. Now let's go on to the easy part, which is finding the inverse of this matrix. That's what the -1 stands for, right? You cannot go ahead and multiply this by this. So finding the inverse is a two-step procedure. First step is to find the determinant of the matrix, and the determinant is given by the formula AD minus BC. And in this matrix here, A is 4, D is 3, B is -2, and C is 2. Recalling how I knew the values of A, D, minus B, C, every typical matrix, 2 by 2 that is in the format of A, B, C, D, right? Okay, great. So moving ahead, when you calculate this in your calculator, straight off the bat, 4 3s are 12, and then you'll get 12. Take away 2 2s are -4, so that's +4, that's 16. So therefore, the determinant of this matrix turned out to be 16. And putting it all together, the inverse would be 1 over the determinant. By interchanging these two, you'll get D, A, changing signs of both, you'll get -B, -C. And substituting all the values you have, the determinant itself is 16 and the formula is 1 over that. Multiply by D is 3. And remember, you are switching these two. So you'll get 4 here. And you are changing the signs of these two. So originally this was -2, so it becomes positive, and this one becomes -2. So there you have it. That's the inverse of that matrix. Now, if they had simply asked you for the inverse of the matrix, this would have been the answer. The inverse of this matrix, right? Now, we want to solve for x and y. Because to solve for x and y, we actually have to take this entire thing and substitute it in here and then multiply. We are actually going to further take that 1 over 16 and we are going to expand brackets by bringing it into each of these terms here. Right, so if you just had to find the inverse, you could have left it outside, because for the sake of multiplication, we are going to bring it inside. Bringing it inside is just straightforward. You'll get 3 over 16, 2 over 16, -2 over 16, and then 4 over 16. Right, and then let's go ahead and work this out. So up top, we had that x. Let me shift this here. Xy was equal to the inverse of this. Now, the inverse of this turned out to be that. So we're going to substitute 3 over 16, -2 over 16, 2 over 16, and 4 over 16. Multiply by 0.4. And to finally find out the values for xy, we just have to matrix multiply. Now, to matrix multiply, you need to remember you always multiply rows by column first. So for this first matrix, you only choose rows. For the second matrix, you choose columns, right? So to get that first value, that first top value for x, we're going to multiply across this way by numbers this way. So always multiply the first number in the first matrix by the first number in the second matrix. Always first by first and second by second, right? So this is going to result in us getting 3 over 16 multiplied by 0. I should have left a little space. Plus, second number is 2 over 16 multiplied by 4. Right? And then to get the second value of, well, the value of y, you're going to multiply negative 2 over 16 by the first value there, that's 0. And you're going to add it to 4 over 16 multiplied by 4. Now, there's no hard and easy way of figuring this out. You just have to do a lot of practice, and sometimes students develop patterns on their own and come up with their own way of remembering how to work this out. All in all, it can get a bit confusing, so look on YouTube for a lot of videos, practice a lot of questions, and once you get accustomed to multiplying matrices, then you wouldn't have any problems solving simultaneous equations using the matrix method, right? Plug this into your calculator and you're actually going to get a half on top and 1 on the bottom. Finally, your final answer will state that x turned out to be a half and y turned out to be equal to 1. Now, if at the end of the day you get some strange values and you want to verify that your answers are correct, you could go back to the original question, which says your equations were 4x minus 2y was 0 and 2x plus 3y was 4. You can choose any one. Let's choose 4x minus 2y being equal to 0, and you can simply substitute the values you got. So you got x to be a half, and then you got y to be 1. Let's see if we get that value of 0. So 4 multiplied by a half. A half of 4 is 2. And 2 multiplied by 1 is 2. 2 take away 2 is 0. So using our values here, we end up getting the 0 that the question had. And similarly, if you try them over here and here, you should get 4. And that's how you know your values are correct and you did not make errors. So if you're doing this question for exams, that's a great way to check and move forward instead of worrying that your values look very weird. So I thought this video was going to be short. This is going to take forever to upload, but I'm glad that I did this video for you guys, and I hope that it helps with matrices in the future. And I'll make more videos because yeah, a little bit more on matrices that you'll still need to know. Okay, so thank you very much. Hope you enjoy. Please comment. Bye.